This question asks us to list all possible rational zeros. And what is going to allow us to solve this question is using the rational zeros theorem. So that theorem says that if our possible rational zeros will be given by the factors of the constant over the leading term. And remember, the leading term is the coefficient on the highest power. So when I see possible rational zeros, the first thing that pops into my mind is C over L. I have to look at the constant factors of the constant over the factors of the leading term. So in this case, our constant is 2. Our leading term is going to be the coefficient on the highest power. The highest power here is 4. Coefficient will be 6. So when I list this out, I'm going to be thinking about the factors of 2 first. So that's just 2 and 1. Over the factors of our leading term, which are going to be 1 and 6. And then also 6 you can break up into 2 and 3. So that's another combination. So we'll have plus or minus 2, plus or minus 3. Okay? Now, of course, our answer is not going to be in this form of C over L. What we have to do is we have to break this big fraction up into several little fractions and write it out very elegantly. So in order to do that, we fix our denominator and run through the numerator. So by that I mean the first thing we would do is we would fix the denominator at 1. So we would have plus or minus 2 over 1 plus or minus 1 over 1. Okay? Then we would fix our denominator at 6. So we would have plus or minus 2 over 6 plus or minus 1 over 6. Then we would fix our denominator at 2. So we'd have plus or minus 2 over 2 plus or minus 1 over 2. Then we would fix our denominator at 3. So we would have plus or minus 2 over 3 plus or minus 1 over 3. Okay? Now, once we go through this, fixing the denominator, run the numerator as 2 and 1, we then sometimes will generate repeats. So we have to look at this long list of numbers that we have and ask ourselves if anything is being repeated here. So 2 over 1 is just 2, 1 over 1 is just 1. 2 over 6, though, that is the same thing as 1/3. And if you look, 1/3 is already in our list. So we are going to completely eliminate that because it already appears in the list. 1 over 6, reduced, is not in the list. 2 over 2, though, is the same thing as 1, and that is in our list. So we have to eliminate that. 1/2 isn't repeated. 2/3 isn't repeated. 1/3 is not repeated. So once we eliminate the repeats, we see we have plus or minus 2. Again, the over 1 is redundant. Plus or minus 1, plus or minus 1/6, plus or minus 1/2, plus or minus 2/3, plus or minus 1/3. And those are our possible rational zeros. It's not saying that all those numbers are zeros. They are just possibilities that we will then test in order to find out if they actually are zeros. So remember, if they ask for possible rational zeros, you're thinking about the constant over the leading. You come up with those factors, fix the denominator, run through the numerator, and then look at if there are any repeats.